Hello, this is Eli. In this video, we're going to cover the database concepts that you're going to need to know to work with databases in your Java programs. Applications are more useful when you can store and retrieve data. Up to this point, your previous assignments have not used data storage or retrieval. So unless you've coded some sort of data storage ability in your apps, when your application stops running, that means it has left short-term memory and your data is gone. Now, I'm aware that we did a assignment where you used a text file, but even text file data storage is limited. So with databases, when an application stops running or leaves RAM, the data will still exist because the data is stored in a database management system, and or the data is part of a database management system, and your data exists outside of random access memory. Now here's a diagram that illustrates an application. So you have an application as depicted by the computer monitor, and then you have a database that's separate from the application. So your application will go out and store data, and it can also retrieve data. So what exactly is a database? For those of you who have not taken uh, a database class yet, a database is a data structure. And as I mentioned before, it allows you to store, retrieve, and organize large amounts of data. Um, Wikipedia also says that it's a group of schemas, tables, views, reports, and other objects. So all of these things are organized into a structure, and you would store data, and you would retrieve data from these tables or entities. So why databases? Well, databases have some major advantages over other data structures. They can store very extremely large amounts of data. They can be organized and they can be optimized in a way that allows extremely fast data retrieval. Consider Google. Google has very large amounts of data, and Google uses a relational database as a backing structure. So, as I mentioned, databases have extremely fast data retrieval because the databases have a backing structure of a B tree. So, a tree is one of the data structures that supports very fast and efficient retrieval of data. A tree has a tree data is retrieved from a tree using an optimal algorithm for searching data. So there's something called time complexity of data retrieval. And more technically, it's known as big O notation. And if you take the data structures class, you'll learn more about time complexity and big O notation. But big O notation is a mathematical notation. It's used to classify algorithms according to their running time or space requirements. So as data or input increases, time can potentially increase, or the time to retrieve data or run that algorithm can increase. And that's not ideal in terms of data retrieval. We don't want the time to run an algorithm or even the space. We don't want those things to increase as data increases, because if you have a very large amount of data like Google, it would take forever to retrieve data. So there are certain algorithms that are optimal for data retrieval. So as the amount of input or data increases, the number of operations required to search can stay the same with some of these algorithms that are optimal for data retrieval. So if the inputs increase, that can potentially impact the time to search a database, the time that's required to search a database. But we don't want an algorithm to increase constantly. So if you look at this middle, let me look at the other slide first. So, as I said, this is known as time complexity. So if we look at the middle, the purple line here, you can see as input increase, the time or the operations increase. And that's not optical. That's not optimal here. What we want is we want something that's horizontal. Horizontal, like these horizontal lines down here. The red one and the blue one. You can't really see the blue one. It's kind of covered by the red one, but they're horizontal lines. These are the optimal or ideal. These are the ideal notations that we would want. So O log n is a time complexity that a B tree has, and it's ideal. So as I was saying, Google uses a B tree like structure and a relational database structure. So if you think about all the data that's in Google, and no matter what type of search you type in, you usually get results within a second. And that's because the backing structure is a B tree, and they're using these big O notation algorithms are uh, that are ideal for retrieving data. So, excuse me. Uh, how do we manipulate a database management system? A database management system typically has two types of statements: DML statements and DDL statements. DML statements are also known as data manipulation language statements. And we use these statements to manipulate the data. And these statements are um, reads, updates, queries, deletes, and inserts. And then there are data definition language statements that we use to define and alter our tables and our databases. There's also something known as CRUD, and CRUD is a word that you may hear out in industry, and it just stands for create, read, update, and delete. The same type of statements that we'll use to manipulate and even define our database. We use the create statement, like create table, to define a table, and then read, update, and delete we'll use to manipulate the data on that table or on our tables. Now, the create table syntax is here listed in this slide, and it just says create table. We use the keywords create table, followed by the table name, and then the column space data types of the data on our table. So when we code a statement like this, it's code statements like this, we can create a table in our database. There's also the ability to read a table, and reading is really just querying your data. You're selecting your data from the table, and the syntax for that is select followed by the columns that you want to select, and then from the table that you want to select from. So instead of the word column one, if we had an employee table that had a name, we would say select. Let's say the employee table had name and address. We would say select name, comma, address from employee table if we wanted to retrieve the name and address. If we wanted to retrieve additional columns, we would list those columns that we want to retrieve. And if we wanted to retrieve all the columns on the table, we would use the asterisk. And the asterisk is a wildcard character that just says return everything from this table. Now, we can also update data on our table. Now, when we update data, we're changing data or changing rows that already exist. So we use update to change rows that already exist. So we use the update the table that we want to update, and then we use the set keyword, and we can say set the column one data to whatever we want to change the data to, comma, column two to whatever we want to change that to, and so forth. And then we can have a condition, and it's good to have a condition, and you should try to use a key, the table's key as your as part of your condition if you can, because updates and deletes are you need to be careful, because if you don't include the proper where condition, you could end up updating more data or updating the entire table. So, and also that's true for delete also. You want to include a condition in the where clause. So to delete, we say delete from table name where some condition is true. And the delete is going to delete entire rows of data. Now, the delete doesn't delete an entire table. We use a different statement for that. We usually use drop, the drop statement, to actually delete an entire table. So remember, delete is for deleting rows of data, and you need to be careful using the delete statement. Now, how are we going to be using databases with our Java programs? Well, there are two types of databases that we can encounter in our Java programs. One is an embedded database, and an embedded database is created behind the scene, and but you can't access the tables, so you can't change data on the tables from outside of your application in an embedded database. But you can, in a non-embedded database, you can access the table through your IDE outside of your application. So the database we're going to be using is called Derby, Derby, Derby. And we're going to be continuing to use NetBeans. And Derby is a relational database system. And the syntax is really the same as SQL. I haven't seen any syntax that's any different than SQL syntax. And SQL stands for Structured Query Language, and it's the language that we use to manipulate our database in our database management system. So, what we have to do in our app is we have to establish a connection to the database. And we typically create the database in the code, in our application, and we establish a connection to it. And then in our code, we would create the tables and perform inserts and insert the data into our tables. And we would also update or query or delete roles or data, and we can do those things inside of our application. We would also add the necessary jar files. Jar files are Java archive files, and they have libraries that we can use in our Java applications. So to use the Derby database, we would have to add the necessary jar files. And you may also have to establish a connection to the database or to the server physically through your IDE. Sometimes when you run your application, doesn't always establish the connection. So if nothing happens when you're running the application, you might need to check to see that you have a connection. So that's all for today. I'm going to show the rest of what you need to know through the Java code. So thank you for joining me.